Welcome to Talkin Science, where we dive into the stories making headlines in the world of science and space. I'm Matt Miller. Dr. Brad Tucker is here. Brad, happy Tuesday.
How's it going?
Really good, my friend. Really good. Let's get the headlines in this, the 23rd week of 2021. And it might be possible to reach another star system in a few decades after a major scientific breakthrough at the ANU. EXOMOON'S orbiting free-floating planets may well have liquid water, and the European Union is gearing up to launch its first wooden satellite later this year. Brad, it's just 2 weeks until our Canberra road trip kicks off. I'm looking forward to recording only the second Talkin Science in person with you. Plus, we're heading over to Questacon and getting inside Tidbinbilla's Operations Centre. It's going to be some cool stuff coming up at the start of July.
And emphasis on cool, given our latest weather and threatening snow forecast we've been having. So the temperature will be as interesting as the science.
It should be very interesting if I'm hoping to sit down with Graham as well and the teddy bear cannon. If it's snowing in the ANU, they're going to be brilliant pictures if we can launch it.
Flying teddy bears in the snow. What's more to love?
It'll make for a good landing. Teddy bear angels.
That's right. Very soft. That's right.
Well, before we get into the show, a quick reminder of the socials. We can find you on Twitter at btucker22. I'm on Twitter at Miramat86. And of course, Trekzone exclusively on Twitter. Plus, find our YouTube channel for the latest eps and on your podcast app of choice. And you can get behind the scenes goss and early access to all Trekzone podcasts by becoming a member today. Click the join button on any Trekzone video on YouTube. Go to the Trekzone/support or put your phone up to the QR code on screen right now. Brad, first up in our headlines, the first seats on Blue Origin that we talked about last week have been sold for $36 million. I got outbid at $34 million. How about you, Brad?
Yeah, look, I mean, the fact is that they're only going up for 11 minutes, which is, 660 seconds. And at 36 million Australian, that's around $180,000 per second. A bit out of my price range.
Absolutely. Well, for the first time in nearly 5 years, a crewed Chinese launch is gearing up. 3 astronauts will spend 3 months in orbit.
Yeah, look, part of an exciting, mission as they're building their space station. This would be kind of the third or the fourth part of doing so, with more planned. And as you said, having those 3 crew going up, which hasn't been for the better part of for almost half a decade. So really ramping up that activity, as we've seen a lot of from China in space.
Canberra researchers, Brad, say they've cracked the code that'll allow us to send a spacecraft to another solar system within a lifetime.
Yeah, this has kind of been a big goal. Is, can we travel to another star system? Now, current rockets or satellites would take tens of thousands of years to get to even the next system to us, Alpha Centauri. Now, Alpha Centauri is 4.2 light years away, meaning the light itself takes 4 years to get here. But as part of the breakthrough Starshot, there's this challenge to say, well, can someone build a system using lasers, potentially reach it in decades rather than tens of thousands of years? And as you said, this new calculation showed that not only is it definitely possible, but the technology maybe isn't as far off as we imagine, that maybe in the coming decades we can do this. So we're really talking about in the span of our current lifetimes, this actually may be achievable.
And as you said, this project is the Breakthrough Starshot probe, and it's going to need to travel about 2,000 times faster than the Voyager spacecraft to make this trip within a lifetime. Are we getting close to warp speed here, Brad?
Look, we're getting as close as anyone has ever imagined. I think that's the exciting thing, is no one really thought you could even go fractions of the speed of light. Right now, the Solar Parker probe, which is approaching its top speed, which would be about 700,000 kilometers an hour, is only 0.05 the speed of light. Right now we are so far away from the speeds that we're talking about. This is a very big change in what we can do, and then actually making it achievable.
Well, the theory goes, if I have it right, that a laser from the ground will propel this probe on its interstellar journey, in a reminder that most science fiction shows overlook this fact that engine power is not always required to be on to travel in space.
Exactly. That's the thing, is that you can actually just use it as a boost to get you going. So the idea is that once you're in space, there's nothing really to slow you down. That is the benefit here. You can just cruise. So if you have something powerful enough to give you a huge acceleration, you will continue at that acceleration. And this is exactly what this mission is trying to do. So if you accelerate something at 20% the speed of light, it will keep going at 20% the speed of light. And that's been the name of the game. And as in a lot of we're talking about, even in current times, that once you leave the Earth, that's the really tricky part, whether it's leaving or having a launch base from the moon, or just in the middle of the void or outside the atmosphere of Earth. That's the key to the fast travel that we're looking at.
And I think we're going to get even better than the current thinking here, because the current thinking is that 100 million powerful lasers grouped together on the ground are going to form 100 gigawatts. There's some scale involved here, Brad, but what's that going to be able to let us do and push this probe towards Alpha Centauri?
Yeah, look, I mean, 100 gigawatts, you're talking about just unfathomable numbers. We're talking about 100 billion watts, 100 billion, we're talking about 250 billion light bulb powers worth of energy, essentially. That sort of power is dramatic. Now, it's not Death Star. We're not really talking about something that's going to disintegrate a planet here because of the power involved, but it's enough to give you that push. But then that means if you can really harness that power, then you're talking about long-range communications at high bandwidths. There's this really big push for laser optical communications, transferring data via lasers, which is much more efficient, and therefore you can transfer more data and more energy. So all these different things really combine in a way that says, hey, this is an exciting idea. And what they show in this paper is how quickly we're coming up with laser technology in its uses and its abilities, that this isn't just a science fiction idea towards the end of the century. This is something that we'll probably achieve in the not too distant future.
I'm just wondering how Voyager 1 and 2 will feel when this launches and shoots straight past it, going really, really fast.
Yeah, look, it's slow and steady wins the race, except in space, where, sometimes that is not the good thing. That's right. Poor Voyager will have been going for 50 years or 60 years when this thing's launched, and it will pass it by within a...
Bye!
Yeah, it's kind of like, sorry, I'm just starting my warm-up jog, so to speak.
Well, Brad, astrophysicists at the LMU have calculated that the moons of planets with no parent star may actually hold liquid water.
Yeah, this is really cool. EXOMOON'S has been obviously a very interesting topic lately with the discovery and the rapid discovery of exoplanets, planets around other stars. And there's always been very good calculations and theories that show that potentially free-floating planets that actually aren't around a star anymore, could be out there. And if there's a planet like that, then there's probably a moon like that around that planet. And then if you combine it to how we look at in our own solar system, some of the moons in Jupiter and Saturn have clear evidence to some degree that there is water around the surface. Now, not directly observed, but very implied based on the other observations we have. So it's a really exciting thing to think about that. Well, maybe this combination means that these moons actually could have water, and therefore then just that propagation of objects in the universe, or in the galaxy rather, dramatically increases.
Well, part of the idea here is that the tidal forces from the planet form a source of heat. And if the moon has about 90% carbon dioxide in its atmosphere, that would produce a greenhouse effect large enough to retain the water in a liquid state. Pretty incredible to think that the moon might be the source of life rather than the planet.
Yeah, and again, this is in this thinking that, well, all right, well, it looks like that's the case of Jupiter and Saturn with all its moons. And yeah, it would be terrible for that free-floating planet, but as you said, maybe it just does enough to actually make the moon survive, and that it have liquid water and therefore can be the place that is habitable rather than the pretty much dead planet be going around. So all these things become quite interesting when you start thinking about the combinations of planets, the way planets can also evolve. How do you get a free-floating planet? Does it stay like that? Is it ejected? Is it kicked out? Does the star change? All these different consequences. So it becomes very interesting when we're talking about the diversity, so to speak, of exoplanets out there.
Now, Brad, I didn't realize that there are over 100 billion planetary nomads out there, and they're not necessarily alone, with Jupiter-sized planets acting as step stars, if you will.
Yeah, we've always seen for a long time, or thought for a long time, that Jupiter is almost its own class. Either it's not quite a failed star, but it's an intermediate star, very close to what we see as brown dwarfs, stars that are very cold themselves, not quite the nuclear force powers as our star, our sun. And therefore, then, well, maybe again, this just isn't that rare. We do think, as you said, that these free-floating large planets could exist. And so it's kind of just as, well, if we can see it in our solar system with Jupiter, and we can see that these Jupiter things or things like Jupiter exist, and they're probably not that rare, we see them quite abundantly, well, then when you put it all together, you can get probably those right environmental characteristics where it does survive, and it is possible to be treated like that environment to allow it to water. So just a really interesting combination here of just showing the vast quantities of things that we're looking at and understanding in our galaxy.
Lastly this week, Brad, the world's first wooden satellite will be launched later this year. It's the Finnish WISA CUBESAT, with the European Space Agency contributing a suite of experimental sensors to the mission. This is going to be one to watch.
Yeah, look, this is kind of an interesting thing because we've talked quite a lot about space junk and it's growing and what happens with satellites that end their lives and all these sorts of issues. Well, this is a very interesting idea that, well, if you can get a wooden satellite to work in space, quite clearly it's going to be very easy to get rid of. It's wood. You deorbit it in the Earth's atmosphere, it's not going to last very long. And this may be a very simple, interesting, sustainable technique of how to deal with our increase in dependency on satellites and at the same time use them and build them in a safe and friendly way.
Well, it's a 10 by 10 by 10 centimetre CubeSat with surface panels of plywood and thought up by Jari Mäkinen, a Finnish writer and broadcaster. Hope I got his name right. His co-founded company Arctic Astronautics has been making replicas for education and hobby purposes of other CubeSats, but his interest in model planes led him to wonder whether this could be done. And as you say, it certainly will bode well for the future for satellites.
Yeah, and look, there's a Japanese group also looking at this. There's obviously a few groups trying to think about how you can do this. So the key is, does it work in space? It will get up. Once you put it on the rocket, it will get into space. The question is, does it survive that trip into space? Lots of satellites in their early testing do fail some of these tests, which is good because that allows you to fix it before it goes up. Then will it operate in space? And the testing, I think they'll do later or soon this year before they put on the rocket, will show, is it possible? And then once it's up there, if it does end up working, it's a very interesting way of potential future space communications. Now, it may not solve everything, but all these little pieces of the pie of dealing with the space junk problem and building more sustainable ways of going into space is absolutely critical if we're going to keep using it and accessing it.
Well, ESA's joining in to analyse how the wooden CubeSat will function in orbit, providing sensors and telemetry. There's also an onboard selfie stick, Brad, so we should be able to get some cool photos after it's deployed, fingers crossed. And also an amateur radio payload, meaning hobbyists can downlink data from the LoRa radio link.
Yeah, look, that's kind of the cool thing, right, is that they're really building it into a way of, as a test, but getting the people and the public involved in this. As you said, amateurs are able to connect with it, which is something that a lot of do, but they're going from the beginning, allowing people to ping and track it, as you said, with those images. And really, as you said, trying to do this first in what could be a very new way of space exploration.
Well, just before we go, Brad, a look ahead to this week's Talkin' Science interview. Associate Professor Niraj Sharma will be beaming in from the University of New South Wales. He led a team of researchers to finding an extraordinary material that does not expand or contract over an extremely wide temperature range and may be one of the most stable materials known. Now, materials with zero expansion are used in high-precision mechanical instruments, control mechanisms, aerospace components, and medical implants for environments in which stability at varying temperatures is critical. That interview will be out on Thursday at 11:30 a.m. GMT. Or if you're watching us in the future, click the card in the top right of the video, follow the links to our website at trekzone.org, or even become a member and get access as soon as it's uploaded tomorrow. Brad, it's great to pick apart the stories of the week with you. We'll do it all again next week.
Thanks.
Keep up to date with Twitter. Catch new podcasts daily on YouTube. Plus, we're beaming to your favorite podcast app 5 days a week. Just search for Trekzone and subscribe.